Advances in technology, increased demand for customer service, efficiency, and excellence present new challenges to us all every day. The genius of American industrial pioneers, with their innovations and advanced manufacturing techniques, has created this fast-paced and growing economy. In today's global marketplace, it is more important than ever for manufacturers to have the right equipment operating efficiently to compete. The enormous variety of hydraulic applications used by industry must offer smooth, continuous operation. Thanks to innovative technology, American companies continue to increase their efficiency, productivity, and profit. The Filtroil Bypass Filtration System is an example of such innovative technology. Filtroil helps manufacturers virtually eliminate costly downtime caused by hydraulic oil contamination. Industry leaders recognize the cause of sticky valves, failing pumps, system overheating, and timing malfunctions as nothing more than a few sub-micron-sized particles of dirt and debris contaminating the oil. These components removed from hydraulic machinery demonstrate the benefits of using the Filtroil Bypass Filtration System. The Filtroil filter minimizes wear of critical components, such as these O-rings used in directional valves. It also virtually eliminates damage from costly bearing failures on pump shafts and other components, as well as excessive deterioration on wear rings within the pump. Clean oil is the only barrier preventing metal-to-metal contact between the vanes and the wear ring. As servo valve technology continues to grow, clean oil will continue to be more critical than ever. The most effective prevention for these problems is the Filtroil Bypass Filtration System. The Filtroil Bypass Filtration System is cost-effective to buy, install, and use, and its filter can be changed while the machine is still running. The system's variety of sizes meets the capacity requirements of most equipment, and its design makes it easy to install. Inline filtration on hydraulic equipment usually removes contaminants between 3 and 10 microns. Contaminants below 3 microns, unless removed by the Filtroil filter, continue to circulate within the machine, creating silt and causing sticky valves and other problems. With the Filtroil Bypass Filtration System, oil from the machine's high-pressure line flows through the system's pressure-compensated flow control valve and into the filter housing at the appropriate flow rate and pressure. It then flows down through the layers of fiber. Larger particles of dirt and debris are trapped in the top layer, and smaller particles are trapped in the middle, more dense layer. The unique engineering of the element increases the lower section's density as oil flows through it, thereby trapping even the smallest particles before releasing the oil into the machine's oil reservoir. This efficient Filtroil 3-stage filtering system removes particles as small as 1/10 of a micron. The level of cleanliness of hydraulic oil is measured by the ISO code. The higher the ISO code, the more the contaminants. Industry guidelines indicate that machines operate best with an ISO code of 16-14-11 or lower. Even brand new oil is not guaranteed clean. It has an ISO code of approximately 21-18-15. Using the Filtroil Bypass Filtration System, oil reaches the ISO code of approximately 16-14-11. Time after time, the Filtroil system has demonstrated its extraordinary value to manufacturers. It will help to extend the life of your machines and ensure their peak performance, resulting in increased productivity and profits. Pioneering more efficient operations is an American tradition. Filtroil has innovated a product that continues that spirit of achievement.
How do microscopic contaminants achieve such large and drastic effects? Contaminants do not have smooth edges. They are irregular in shape and have sharp edges that cause abrasion as they scrape metal surfaces, creating additional contaminants. Let's follow contaminants in the hydraulic oil as it is drawn from the tank through the hose to the pump. You can see the contaminant's irregular shape with sharp edges and corners. Once the oil and contaminants are drawn into the rotating group of the pump, the contaminants can cause damage in several ways. The larger particles cannot pass through but will break up as they strike the stationary port plate, shown here in yellow, and cause accelerated wear. Notice how the contaminants break down the edges of the port plate. As we look at other ways contamination can cause problems, we turn the animation of the pump 90 degrees onto its side. Particles can lodge between the piston and the brass slipper foot, shown here in purple, causing it to jam. The contaminants can also scrape walls between the barrel and piston. Electro-hydraulic valves are more susceptible to contaminant damage because the clearances are even smaller, as small as 3 to 4 microns. Some of the particles naturally adhere to the imperfections in the wall or because of the electromagnetic conditions in the valve. This buildup, or siltation, can either slow the spool, causing sluggishness, or make the spool hesitate, causing jerkiness in the system. Over time, the contaminants can cause wear on the spool that results in leakage. And sometimes, a large particle can become lodged and block the motion in the valve. All the particles then move on to the filter. Do not assume the filter removes all contaminants in a single pass. As the oil moves through the filter media, many of the particles are trapped, but a few, some large and some small, travel through the media and return to the system through the center tube. Even high-efficiency filters do not remove all contaminants. Contamination can affect any machine with hydraulic capabilities. A hoe that swings too far on a backhoe loader, or one track that runs faster than the other can be a sign of contamination. Equipment owners and operators also see other common effects of hydraulic system contamination, including cylinder drift, jerky steering, slower performance, erratic operation, shorter service intervals, higher operating costs, lower productivity, and possible catastrophic failure. The pump is one of the most expensive components to fix on a hydraulic system, and in the event of a catastrophic failure, it may take days or even weeks to repair a contaminated hydraulic system. That's why it's so important that the means exist today to prevent such problems from occurring. The products and procedures of ultra-clean technologies can protect you from such nightmares.